Good afternoon, and thank you very much for attending this water webinar. My name is Ana Sancho, and I take care of water, agriculture, and research projects for Europe and America. I have a background in agriculture engineering, and also have been working for Libelium and the IoT sector during the last 5 years and a half. This webinar will be recorded and uploaded to our website in a couple of days. Also, at the end of the session, you will have the chance to ask questions to Aridea and myself. Additionally, if you need any further information, you can also contact our sales department at sales@libelium.com. Thanks again, and let's start. Just as a brief introduction, Libelium designs and manufactures hardware in order to provide wireless sensor networks for system integrators, engineering companies, large corporations, etc. So they can deliver reliable Internet of Things and M2M solutions with a minimum time to market. We try to find solutions to real problems, generating real-time data for IoT projects. Lastly, Libelium was founded in 2006 and has its headquarters in Zaragoza, Spain. So the case study we're going to talk about today and the project is a smart water technology that provides safe and clean water to Indigenous communities in Canada. The project mentioned on the case study was performed by Aridea, based on Libelium's technology, and in collaboration with Saskatel. Aridea is a system integrator with more than 6 years of experience and also is capable of customizing projects and deploying turnkey solutions. Rob Moore will be joining the webinar as a special guest and will be also available for questions at the end of the webinar. Also, I wanted to note that this is an example of how the Internet of Things has great possibilities in the water sector. Monitoring the quality of water and then reducing costs and losses, also making decisions based on facts. The ability to receive real-time real-time alerts through a mobile application or SMS allows to detect different pollutants and also to be more efficient with the uses of human and natural resources. IoT can help enhance the life quality of isolated communities in remote areas. Now going into the case study, just to give you some background, Libelium, the First Nation, represents more than 50 nations and 50 Indigenous languages from 634 communities in Canada. Many of these communities have been living under boil water advisories for decades, and this is something that happens in their daily lives. Collecting the water with a pot and putting it in a stove to boil. This has become a routine also to avoid contracting waterborne illnesses. In this case, Libelium's partners company, Aridea Solutions, which is based in West Virginia, USA, is currently, did develop the project, but is also currently performing a joint pilot project with, like I mentioned before, Saskatel, which is based in the province of Saskatchewan, Canada, and which is using Plug and Sense platform to help predict harmful water levels in the water treatment facilities. Also, following the Sustainable Development Goals of the Organization of the United Nations, the Canadian government wants to guarantee the access to safe, clean water to these Indigenous communities. This project helps to achieve the following goals: clean water and sanitation, to reduce inequalities, sustainable cities and communities, and also responsible consumption and production. The technology used, like I mentioned before, is Libelium Smart Water Extreme Plug and Sense, with sensors to measure water deepness and chemistry elements. The data was sent using 4G. Saskatel was providing the SIM cards, and it was communicating directly to the Aridea Stereolytics Portal Cloud platform, which has data analytics and also intelligence. They chose Libelium's because of its flexibility, horizontal platform, and much more features. The smart water solution can measure basic parameters of water like temperature, dissolved oxygen, electrical conductivity, pH, etc., and also chemical parameters through the MANTA sensor probe, like, for example, nitrates, nitrates, calcium, etc. What are the advantages of using smart water extreme sensors and technology? Well, first of all, wide range of connectivity options, worldwide and geographically. You can go from LoRaWAN, NB-IoT, 4G, Sigfox, different radio protocols with different frequencies. Also, a higher accuracy, top-level sensors, they are optical, lower maintenance and calibration, new parameters, and it has a very good performance in salted water. Now, I would like to introduce you to Rob Moore from Aridia, whom is going to speak a little bit about the company and is going to give you more details of the project. Rob?
Thank you, Anna. I appreciate Libelium for allowing me to participate in today's webinar. As Anna mentioned, my name is Rob Moore, and I'm the Vice President of Solutions Development at Aridia. Today, I'll be discussing how Aridia was able to leverage IoT to supply clean drinking water for Canada's Indigenous communities. Let's walk through a case study to show how IoT technology from Aridia and Libelium are currently being used today in one of these communities. But first, allow me to give you some background on our company. Aridia is a US-based company headquartered in Charleston, West Virginia. Aridia was founded in 2013 by a group of IT professionals that shared a passion for technology and protecting the earth. But now let's move on to the location of our use case. A valued business partner recently reached out to Aridia to solve a unique environmental challenge in a remote area of the province of Saskatchewan. Saskatchewan is located in central Canada. Here we find a country with a diverse history and a proud Indigenous heritage. However, these proud cultures are now faced with many challenges in today's society. One such challenge has been the supply of clean drinking water to the Indigenous communities of Canada. Canada is a very large country with communities of Native people living sometimes hundreds of kilometers apart in remote areas with very little infrastructure joining these communities. Many of these communities have been plagued by broken or damaged water treatment facilities and have been under boil water advisories for several years. I'd like to invite everyone on today's webinar to imagine your own home for a moment. Every time you want to use the water from your faucet, you must first place it in a large pot and boil it, and then allow it time to cool before you can even use it. So in response to the challenge of supplying clean drinking water, Indigenous Services Canada has stated a mission to eliminate all long-term boil water advisories on all First Nation communities by March of 2021. A long-term boil advisory is defined as an advisory that has been in effect for an excess of 1 year. As you can see, since the program's inception in 2015, there has been much progress made. However, there is also much more work to be done to reach the aggressive goal of zero long-term boil water advisories. In partnership with our Canadian partner SaskTel, Aridia discovered that the Cowessess community, located deep in the heart of rural province of Saskatchewan, was struggling with repeated boil water advisories from aging technology and infrastructure. During our evaluation of the Cowessess First Nation water treatment process, our team discovered several different technologies being used to manage different parts of the infrastructure. Most of these systems were complex, old, and in disrepair. We propose using flexible IoT-based systems to monitor key points within the Cowessess infrastructure. One key area of concern was a booster station that was used to pump water from the main water treatment plant to a reservoir several miles away. The issue was that the booster pump was being manually actuated to fill the reservoir directly, supplying water to the Cowessess community. The pump could take several hours to fill the reservoir. If the pump was not turned off promptly, the reservoir would overflow, and the result was contamination of the drinking water supply for the community. This has become a repeated event in Cowessess' recent history, unfortunately. Our pilot for adding IoT technology to the existing water treatment infrastructure was simple, but yet effective. We integrated a full Teralytics Edge unit based on Libelium's Smart Water Extreme plug-and-sense platform. The Teralytics Edge was interfaced with a pressure transducer to accurately detect the depth of the water in the reservoir. We set thresholds in our Teralytics portal to alert the customer via an SMS message once the water levels approach unsafe levels. Since the introduction of our pilot, we have alerted the customer on 8 separate events and averted potential overflow situations. These overflow events are a leading cause of water contamination and also lead to boil water advisories. Now that the pilot is complete, we are proposing a more comprehensive monitoring solution by working with SaskTel and other local partners to build a solution that can easily be maintained by the customer without reliance on complex legacy systems. Our goal is to provide a modern but simple system based on IoT that will empower the customer to take a more active role in the understanding and maintenance of the solution. To give everyone on today's webinar an understandable comparison of legacy systems versus modern IoT solutions, imagine an older legacy system such as a telephone and an IoT-based system as a smartphone. Although the smartphone is much more complex, its intuitive design allows the end user to manage and maintain the health of the device with a much quicker learning curve. Also, the smartphone is highly customizable and can easily be adapted to changing customer requirements. So, what are the next steps in using IoT in remote areas with aging legacy infrastructure? Can we combine IoT with even newer, more powerful technologies like AI to further enhance these systems to help Calluses and similar communities? Our team at Iridia says yes. The power of IoT is not only how it can replace legacy systems, but how IoT can enhance legacy systems to solve new and unfolding problems as never before possible. During our proof of concept with the Calluses community, we learned that 2 neighboring First Nation water plants have been completely lost to devastating fires this past winter. The cause of these fires was never determined. We believe that the use of our same flexible Teralytics platform that's currently being used to determine key water levels at Calluses, we can also easily monitor ambient conditions of the water plant, such as luminosity, carbon dioxide, temperature, and humidity. We propose using an array of inexpensive sensors and combining this with AI and machine learning to establish a normal baseline of operation. Once this data set has been learned and a baseline established, it would alert public works officials of any detected anomalies at the plant. We feel that this could act as an early warning to potential hazards such as fire. At Iridia, we feel that by creating an ecosystem of companies that have the customer's best interest at heart, we can make a difference in saving our planet. The most effective way of accomplishing this is to collaborate with the best and most advanced companies, such as Libelium and SaskTel. When these companies collaborate for the common good of the earth and its people, we can accomplish amazing things. Thank you for allowing me to share this story with you. This use case demonstrates one application of our deep water monitoring kit available in the IoT marketplace. I hope you come away inspired on today's webinar and begin working on your own IoT project and other new technologies to help create a smart Earth. Thank you.
Thank you very much, Rob. And now, please feel free to ask any questions. I'll be happy to assist. Rob is at the other side of the chat also, so go ahead. Just feel free to ask any questions. We do not have a sensor for chlorophyll in water, I believe. But I mean, we have seen in the market some other sensors. We can evaluate the integration of the sensor. We do sell in India. We have a distributor in India. It's called Intrinsic. If you're interested, send us an email, please, to sales@libelium.com, and we will redirect you to the distributor. Webinar is completed, yes. Now we have a question for Rob. He'll be answering the question in the chat. We do sell in Iran. If you are interested, just send us your request to sales@libelium.com. We don't have a distributor in Bangladesh. You can purchase any equipment directly from us. I think in the Indian market we already have a distributor, and everything goes through the distributor. It's called Intrinsic. It would work. Can you please specify? Do you have any questions related to the case study, the technology? To change the sensors, you mean, or how frequently do you have to change the these sensors use infrared technology. You need to calibrate them and clean them every so and so, but the calibration and maintenance procedure is much longer than traditional sensors. Usually around 6 months, 12 months, depending on the water conditions. Can we use this for RO plants? What can you please clarify? About calibration frequency, I think already mentioned that, which is the range temperature. I believe, I don't know, up to 60, but in any case, it won't go below 0 because water gets frozen. You think that if we make a range of the set of sensors with chlorophyll of a resource, I believe we can do that. Reverse osmosis, I don't think so. Javier Pizarro, you can contact the sales department and mention myself, and we can study the project in deep and then give you a solution, if that's okay. More questions about the sensors, technology? I mean, I mentioned that one of the advantages of using Libelium for the water sector is that the customer can choose from a wide range of connectivity options. I'm not sure if that part was mentioned if you guys heard that part in the beginning of the presentation. So if you don't have coverage, you can always use LoRaWAN or radio technology or Sigfox. Yes, so I sent a link in the beginning of the chat. You can go to libelium.com, and in products there's a part that says training courses. If you click on that, you'll see at the end of the page a section which is called webinars. So everything that we do is posted there. You can download the presentations, rewatch the webinars again. Let me see, is there any kind of actuation methods as pressure control available apart from the water quality? No, we don't do actuators. Our solution, the basic one that we have in our portfolio, is meant to capture the data and send the data wirelessly. Then we do custom options. Rob from Aridia is expert in doing this kind of custom solutions and providing turnkey solutions, or we can either do it here from Libelium, but I usually recommend to work with a partner that has already all that expertise. Who actually designed the solution? The water extreme solution was designed here at Libelium's corporate office, and then depending on the sensors, or if we need to go with custom product like putting the sensors in a buoy, then we collaborate with Aridia and Rob Moore. What about chlorine determination? The Mante probe from the water extreme line has also available chlorine, but you need to purchase the Manta probe and then add the sensors that you want to use. It's a little bit more pricey than using regular Ion Pro sensors. More questions? Anything related to the project? I mean, with Rob Moore, Aridia, we have done other collaborations, and some of them are visible in our in our website in the case study section. We have done a project with them for the beluga whales. They have designed buoys for ocean water. Also, we have done a different case study in the Ohio River. I mean, we do a lot of projects with them. Some of them cannot be visible because we signed NDAs, and other ones we do publish as case studies. So if you want to take a look at the different case studies, they'll give you different examples of what we do in the water sector. Any other questions? How many maximum number of physical and chemical sensors can be integrated in a single system? So each plugin sends 6 different sensors. I think I sent also the Smart Water Chemical Guide, which can give you an idea of the amount of sensors we have integrated. And also one of the sockets allows the Manta probe. The Manta probe has also, I believe, 5 different sockets to add 5 different parameters. Okay, so I mean, you can measure a lot of different parameters in just one single node. The only thing you need to keep in mind, if you add a lot of sensors and you have a high frequency of measurement, then you might need to connect the node to a direct source of energy. How can we proceed for a river in Bangladesh? We would need to analyze a little bit the project and the environment of the river, the site. Where would you like to install, dimensions? I mean, we would need to study a little bit, see the project needs, and then the parameters you want to measure, and then we would recommend the best suitable technology for the project. If you are interested, you can send us an email to sales@libelium.com. Just mention the project characteristics or project details, and we'll give you a suggestion. More questions? Thank you. I'm sorry about the technical issues in the beginning. And then I'm sorry that you didn't hear the first slide of the presentation. But, and Rob had also technical difficulties. But if you want more information about Aridia or what they do, you can also go to their site. Rob, if you can share your site's details and the contact email information. And if you have any other questions, comments, if you have a project in mind. I mean, the good thing about collaborating with Aridia is that with just Libelium, sometimes it's a bit difficult and we have challenges of deploying in very remote areas. But then when we collaborate with Aridia, then makes things much more simple, and they provide the extras that here from Libelium corporate office we cannot provide. And also they have like a very powerful and nice Teralytics software platform with artificial intelligence, and that makes customer experience so much better. Yes, so Saskatoon contact Libelium, and then I put Saskatoon in contact with Rob Moore for this project, and after 6 months, I mean, it went really fast. The project started working. It's still ongoing, and we hope to install in much more sites. Anything else? Come on, feel free to ask any questions now. Okay, so if that's it, again, you can contact sales@libelium.com if you have any questions. And if not, well, we will see each other in any other webinar. Yes, battery life depends on data polling frequency. That's true. Yes, that's correct. This will be my last question. Yes, if you measure every second, every 2 seconds, the battery lifetime is going to be shorter. Eventually, you will need, well, for that, if you measure every second or 2 seconds, for sure, you will need to have any device connected to a source of energy, but also the battery lifetime is going to get shorter. You will probably need to replace the battery sooner than if you measure every 15, 30 minutes. In some case scenarios, it is necessary to measure more frequently than in others. And depending on the frequency, yes, you might have a higher energy consumption and then have to replace the battery sooner. Yes, so we have applied machine learning, but that's on the cloud side, and you will need to speak with Rob regarding this topic. Okay. Again, thank you so much for attending the webinar, and then sorry about the beginning. And I hope to see you guys soon. And if you need anything, feel free to contact me. Thank you very much.